for VSL since March 1994, and I'm a member of Working Group 1 of the Joint Committee for Guides in Metrology, also known as the GUM Working Group. I'm representing in that working group ISO, and the GUM is, as most of you probably know, the Guides to the Expression of Uncertainty in Measurement. Why a webinar about data science and modeling? Well, measurement solutions require a proper treatment of data. Many applications of us and also of our customers require support in this area. Digitalization is, of course, a recurring topic, and that requires measurement systems to be connected and capable of communicating with each other. And artificial intelligence finally is finding its way into measurements, and those applications need to be robust, accurate, and reliable, as we are used to from many of the measurement infrastructure that we encounter in our daily lives. What is data science? Well, data science is a multidisciplinary field that uses scientific methods, algorithms, and systems to extract actionable insights, patterns, and predictions from structured and unstructured data. Well, that is a whole mouthful, but that will become apparent in the next few slides. And modeling is probably the part that many of you understand better. That is translating a real-world situation in a mathematical representation. And let's say at the bottom of practically every measurement that we encounter in our lives, there is some model underneath, and that is used to generate the measurement results and also a vehicle to evaluate measurement uncertainty. Some examples of modeling. Well, probably the best known modeling example is something that you will consult probably at least once a day. That is the weather forecast. But modeling is also used to combat net congestion in electrical grids, imaging in healthcare. And regarding data science, well, the recommendations that you get from Netflix, Amazon, or YouTube, for that matter, for a product, a movie, or something else that you might like based on your previous interaction with the system. Extraction of features of flow measurement data in a gas grid, and discovering patterns in data from sensor networks. On the right-hand side on this slide, you see a graph from a primary standard from chemistry. Here you see the permeation or the mass loss of a permeation tube. And if you look at the blue residuals in the center of the graph, you clearly see that those are not randomly distributed, but there are patterns in that. And that is where we use also ourselves data science techniques to model those patterns to get reliable estimates and a duly evaluated measurement uncertainty. Mathematics, statistics play an important role in measurements. Many measurements are embedded in larger systems, such as an infrastructure for the distribution of water, gas, and electricity. And you can imagine that those systems are operated with computers and algorithms. Reliable results require good measurement methods and advanced data processing. The models are the backbone of measurement methods and also the data processing. And mathematics and probability theory are the basis for evaluating measurement uncertainty. And measurement uncertainty we use, of course, to take informed decisions. On the right-hand side, you see a picture of a sensor network. And in sensor networks, well, you have a lot of sensors placed at locations. but those locations are not always the location where you're interested in a measurement. So you use mathematics and statistics to get an estimate at the point of interest. We use data science and modeling, of course, also within VSL. The group provides methods, algorithms, software for data processing and uncertainty evaluation. We develop, of course, together with other technical fields, measurement models. We are leading in the development of applications of artificial intelligence, machine learning, data analysis, modeling, and digitalization. And we are the experts in digital systems for data collection, curation, storage, and retrieval. VSL is the National Measurement Institute of the Netherlands. We are a private institute with a public task on behalf of the Dutch national government. We maintain the national measurement standards, and thereby we support trade, commerce, industry, legislation and regulations, and also innovation. We have various laboratories. They are depicted on this slide. I'm not going to read all of them aloud, but in these laboratories we perform calibrations. We produce in some of them also reference materials, and we also provide proficiency testing. Here you see some of our national measurement standards for mass, for gas flow, for light, for chemistry, for time, and for geometry. And metrology and measurement standards have an important impact on society. We support healthcare, trade, commerce, industry, and science. And the bottom line is that for reliable measurements, you need reliable measurements for making useful comparisons and take reliable decisions. And for that, you need uniform measurement units and measurement values with known uncertainties. Those measurement standards also play a role in our strategic plan that is developed around 6 themes: the energy transition, healthy living space under pressure, reinforcing economic resilience, increasing costs of health care, geopolitical threats, and digitalization and the rise of artificial intelligence. And in all these domains, our data science and modeling group is active, sometimes in a supporting role and sometimes in a leading role. We operate, of course, worldwide, and notwithstanding all kinds of geopolitical things, metrology is still for the whole planet an anchoring point, and also one of the points where we agree that it is important to collaborate and make sure that national measurement standards are comparable. The Netherlands is a signatory of the Meter Convention. There is a mutual recognition arrangement from the International Committee of Weights and Measures, the CIPM. And that treaty is very important because that ensures that not only our certificates, but in the end also the certificates of calibration and laboratories and the test reports from testing laboratories are accepted globally. Of course, we need to demonstrate that our measurement standards are equivalent. And we do that in our own kinds of proficiency testing called key comparisons. Unlike proficiency testing, where the identity of the participants is not disclosed from the key comparisons, you can find in the key comparison database the reports with the names of the institutes and the results they produced. So if you're interested to see how we are doing in those comparisons, please have a look at the key comparison database. And of course, the participation in these comparisons we do to underpin our calibration and measurement capabilities. Data science and modeling plays an important role when we are the coordinator of a key comparison. We do often the modeling, sometimes also the data processing, and help the coordinator with the interpretation of the data. We participate in research and metrology networks in Europe. They are organized and governed by Euromed, the European Association of the National Metrology Institutes. There are quite a number of these European metrology networks, and the idea behind these networks is that not every country has to develop all the things by themselves, but that we have a pan-European approach to the metrological demands on this continent, and make sure that things like the energy transition, improvements in healthcare, climate observation, and many other things are done in an efficient and robust way. Then digitalization, I already mentioned that. We have in several research projects activities related to machine learning, the creation of digital twins, so let's say a mathematical copy of some real-world system, sensor networks, among others for air quality, time series analysis, digital certificates we are working on, the automation of business processes, data management and security, and institute-wide we are developing an API, an interface between our databases and our software, so that data can be accessed company-wide, of course, with all the security measures that are associated with that. And that is also where data science and modeling is playing a key role. What does that mean for you? Well, and many of you will be organizations like laboratories or other organizations having automated systems. Many of you may also need to implement, just as us, the requirements of ISO 17025, which contains quite a number of requirements with respect to retaining laboratory records, the evaluation of measurement uncertainty, the validation of methods, data security and access, and checks on calculations and data transfers. We support our customers in these areas, partly based on our experience also with laboratory accreditation. We also have laboratory accreditations ourselves, but also partly based on our expertise in data science and modeling. We have a certification according to ISO IEC 27001, which is about data security. So if you have such a system in place, we know what it entails, and we also know what the ins and outs of such systems are. We organize quite a wide variety of training activities, and the first two on this list are quite generic: general metrology and the evaluation of measurement uncertainty. We also have training courses which are much more focused on a particular technological fields, like dosimetry, temperature measurements, electrical measurements, gas metrology, gas flow measurements. We have an overview on our website, and we also organize a lot of customized courses. So if you have a need for a training course related to measurements, please feel free to contact us. We also provide support to implementing standards. We, of course, use also quite a few ISO, IEC, and/or EN standards for our own activities. We also have done that for other organizations, like, for example, for the ISO 10723, the performance evaluation of online natural gas analyzers, ISO 6143, regression software, and we have helped many organizations with their uncertainty budgets as required by ISO 17025. That support can, of course, have different forms. It can be in the form of translating models and algorithms into computer applications, the evaluation of measurement uncertainty, the validation of software, and the assessment of the performance of laboratory information management systems. We can also help you with the implementation of the calibration results that you receive when you send an instrument for calibration. Many organizations use often very high-end measurement standards and equipment to have small corrections so that they do not need really to care about those. That, of course, comes with a substantial extra investment. For example, for a digital multimeter with 6.5 digits versus 8.5 digits, that is a difference between 2.5 and 15 kilo euros. And we can, of course, help you in making sure that your workflow appreciates the calibration data so that you can buy a simpler equipment as far as, of course, your applications permit. Regression software, well, I think that most of you will fit straight lines or something else in your daily work. You may or may not have wondered, well, how well is my software doing that? Many regression software that is out there lacks robustness and stability. Do you see that on first hand? Well, sometimes, and if you see it, then it should immediately alarm you. But sometimes it simply goes unnoticed until a customer or starts complaining or you have a poor performance in a proficiency test. What we can do is we can assess the performance of your software. We can also provide you with data sets with known outcomes so that you can assess your software yourself. We can also create data sets that mimic the performance of software for new applications and services. And of course, we can also provide you with the software themselves. Now I'm turning to some practical cases that we have dealt with in the past. First, the quality assessment of software, not specifically regression software, but all kinds of calculation software. As I said, many organizations have a quality system, and that requires that your software is validated or at least verified so that it operates correctly. What we can offer is such a verification and, of course, provides objective evidence that the software, for example, for fitting geometric elements or filtering roughness parameters or fluid properties in flow computers performs according to the requirements. And of course, you can use that evidence to convince your customers, your auditors, and they can, of course, with that evidence also persuade their customers. We also provide expert opinions. For example, a client discovered an ambient conditions related systematic error, which in the measurement results, which required a correction. They came up with a proposal, but wanted to know whether that proposal was metrologically sound and defensible. We reviewed that proposal and provided evidence in the form of a report for our findings and some recommendations. And the customer could had a fit-for-purpose correction and parts of its validation already documented. We also occasionally prepare an expert opinion for court cases. A flow meter had been used outside its specifications in a case where billing was performed based on measured values. And as you probably know, that should, of course, be within the specifications. There we have performed scenario analysis resulting in 4 possible values for the potential measurement error of the flow meter. And on the basis of that, the client had a solid expert report that he could use in the court proceedings. Instruments can, of course, be non-conforming. Sometimes you discover that immediately, and sometimes you discover that later, or actually a little bit too late. Of course, this was also a case where billing was done on the basis of equipment that had measurement errors that were too high according to the legally allowed specifications. We developed a measurement plan, analyzed the data, and wrote a statistical impact analysis report for the client, so that the client had a better understanding of the problem, which could be used in contact with the regulators to address the problem, and also to estimate the impact of the non-conforming instruments. Many of you need to propagate measurement uncertainty, and sometimes that you do that through a fairly simple equation, and then there's not too much effort needed. We can also do that on complete algorithms with the well-known law of propagation of uncertainty. And by doing so, we can provide a solution that is fit for purpose and will also be accepted by your accreditation body during a next assessment of your quality system. Last but not least, something about AI. This picture shows several areas where our research and development activities concerning AI, machine learning are taking place, like in grid optimization, predictive maintenance, and other sorts of predictions, smart grids, the Internet of Things. And we are definitely not the party that is the biggest on this planet in developing applications. We are much more concerned and focused on defining proper performance metrics, to look at the uncertainty evaluation of the model parameters and the predictions coming from machine learning and other AI applications, the performance of machine learning models, conformity assessment, which involves machine learning and AI, and also the soft sensors that I already showed for the sensor network. So basically, a measurement taken in a network or a grid at a point where no measurement equipment is installed. If you would like to learn more about some of our research and development activities, please have a look at the websites of Grid Data and Smart GasNet. And if you have any questions about that, you will also find there a point of contact to ask your questions. And finally, if you got inspired, please feel free to contact us through the contact form on the website or through the QR codes, and find out how we can support your organization in the challenges that you have in this area. Thank you very much for your attention.
Yeah, so thank you, Adriaan, for the great webinar, and I hope we've been able to provide all of you with some insights on the challenges and the topics that relate to data science and modeling. This part concludes the webinar presentation itself, and we will now transition into the question and answer portion. So hopefully the content we've provided you with enable you to critically assess also some of your own processes and measurements. If you have any questions, now is the moment to type them in the chat or in the Q&A, and we will try to answer them on screen. Or you can use the QR code indeed to contact us through the website itself with any follow-up questions that you might have. I see some first questions coming in. First one by Francisco. So how does the new FUM version is intended to address current challenges of reliability with data modeling and AI?
Well, I think that a new part to the GUM on AI is still something that needs quite some time. But there is for modeling a document that is part 6 of the GUM, and that gives guidance on developing measurement models, and that describes also in basic terms how we do the modeling for ourselves and for our customers. Okay, thank you. I hope that provided an answer for you, Francisco. There's another question by Majid. It's thanks for your talk. In your slides, I saw something about quantum technology. Does that mean that VSL is actively working on quantum metrology techniques as well? Is there a department in this direction at VSL? Yes, there is. We are working on various aspects of quantum technology, and I would suggest that if you have specific questions for that group, that you use the contact form from the websites, and your questions will be forwarded to the colleagues who can answer those. There are several departments involved in quantum metrology, hence my suggestion to use the contact form for that. There's a question by Erik van der Werf. Will Bayesian statistical methods be included in the new GUM? To some extent, they are already in the GUM, and I think that's one of the developments in the future will indeed be also a part of the GUM describing Bayesian methods. But Bayesian methods in general fit very well in the framework of the GUM. All right, let's see. We wait a couple more seconds if any remaining questions pop up, and if not, then I would like to thank Adriaan once more for his presentation on the details about data science and modeling. And feel free to reach out to us indeed if you have any afterthoughts after today's insights.